Hello, my name is Tandina Wagner. I write the Ecology Interventions blog, and I think that biodiversity is a lot more complex and important than we give credit for, but also we don't really immediately think of the ways that it's important. So I just wanted to spend a little time on that. So the very simple statement you can say is that biodiversity is the variety of life. That's why it's important, but that means a lot of things that don't immediately jump to mind. It's also frequently used as an indicator of ecosystem health, although they aren't one and the same. So I'll just cover the basics of why biodiversity is important. I will talk about the flaws with using biodiversity as an indicator of general well-being of our environment, and the many ways that recording biodiversity is also difficult. I'll talk about biodiversity's relationship to climate change, which I think will be surprising to you. And I'll talk a little bit about biodiversity in the context of where it's been, where it's going, and the like huge grand scheme of things. So first of all, why is biodiversity important is a very simple, obvious thing, but there's many other less obvious aspects to it. So we like it. That is one of the biggest reasons that biodiversity is important. Humans love biodiversity. Like, I don't think we should overlook that. Straightforward, obvious, still important. Why do we like it? Well, we like the way it looks. We appreciate just complexity. We're kind of drawn to it. There's all these sporting activities, collecting and identifying, but also kind of a little more um, elitist, I guess. We have curious about where we come from, and biodiversity is a look into the other types of life and ways that things could have been. Uh, Biodiversity is awe-inspiring. I don't know what else to say. Then a lot of people tell you that biodiversity is important because it helps resilience and recovery of our environments. And I just want to point out that yes, this is true and this is important. It's also a little bit cyclical because it's kind of like biodiversity is important because it protects biodiversity. So we might want to go in a little bit more than that. There's disturbance and how it affects the environment, again, cyclical, or it's how it affects us, which, yeah, let's talk about that. So biodiversity and the fundamental processes are really closely tied together. Biodiversity is a stabilizing force. Without functioning ecosystems and environments, a lot of things we take for granted could no longer be the way they've always been. So I don't think it's exaggeration to say that like water purification, air purification, waste cycling, all these things that we always counted on and they've never been a problem could become a problem if our environment degrades too far. Disease regulation, flood regulation, storm regulation, temperature, like wildly swinging seasons, fire control, erosion control, carbon sequestration to prevent climate change, pollination, that can break down, and population regulation of all kinds. So like something like trees aren't normally, well, it's not a good example because they grow slowly, but uh, other types of fast-growing plants are not normally a problem, but they can become a problem if their population goes out of control because other things in the ecosystem have gone haywire. So like things that are not normally a problem can become a big frustration. Like there's just too many flies, for example. So I just want to take a note of that. That's one of the ways that biodiversity is critical. And a personal example, these are the sorts of ways that you might experience in your life how biodiversity might impact you. I was in Boulder when there was fires in the Poudre Canyon. After that, there was just kind of a regular rainstorm, but the combination was quite impactful. The streams turned black and the road washed out, I guess because the water was able to run across the ground a lot faster than usual, got into the stream much fuller, and then it just was more powerful. Um, and on top of that, there was tons of costs because the sediment that got into the water also got into pipes and infrastructure. And so fixing and unclogging all of that was just an expensive operation. But a little less likely for you to encounter, biodiversity also has wider impacts on our future. So one of the things about biodiversity is it's a repository of all the types of things that life does and all the techniques that it can use. So that's like genes, uh, genetics, or sorry, I mean that, genetics and chemical pathways and like physical function or like physical body interlocking type mechanisms. So, for example, I have the picture of the skin on a shark, which is incredibly water dynamic. So those types of things are things that we can learn from and we'll probably copy and use once we understand them better. And so we can take those and then use them for our own purposes down the line as we research. I mean, everyone knows the story about Velcro, and the shark skin has been used to make swimsuits, but there's lots and lots of other applications. One of the pictures I have here is of a plant. They're able to increase the growth of it like 40% because of changing the rubisco absorption of carbon. At least I think it's carbon. So there's just lots of ways that we can improve our crops, improve our materials, improve our technology. So biodiversity is a repository of all the potential future technology. And last but not least, kind of coming back to the first example, I think this is different though. We treasure biodiversity because we consider it a wealth of goodness that we want to pass on to future generations. It's a sign of our heritage, our childhood, and just kind of the goodness of our traditions. And this, I think, is universal across all kinds of cultures. We call it many different things. We say it's sacred, it's our legacy. There's lots of words for it, but this kind of importance of passing on a good life to our future generations. Another potential example is just straight up resources. Mostly this doesn't apply because anytime there's something that we can grow in the wild or harvest in the wild, we can grow it better cultivated, but there's some exceptions. For example, it doesn't make sense to grow grazing land frequently because it's just freely available. There's plenty of it, but it's a resource that we rely upon. If it weren't there, we'd have to do it ourselves. Mushrooms, we cannot cultivate. Many of the varieties we can't cultivate right now, so we have to collect them from the wild. And then some things, just the fact that it comes from the wilderness can't be replaced, whether it's a selling point or whether it's a tradition. You can't have a tradition that doesn't take place in the natural environment. It would not be the same. I might have missed some. This is my best to be comprehensive, but it's easy to forget many of the other ways that biodiversity affects us and is important to us because it's kind of so fundamental. So I also want to talk about what biodiversity is not and some of the kind of misperceptions you might have about measuring it and so forth. Let me just dive right in and give an example. So in the desert, there are watering holes where there is a massive biodiversity as animals gather there, as plants grow there and nowhere else. So there's just like this brilliant hotspot of biodiversity in the desert, but then the rest of the desert is pretty lackluster in terms of biodiversity. So it can be concentrated, it won't be distributed evenly. Now, that means that it's hypercritical to conserve the watering hole because the rest of the life depends upon it one way or another. But that also doesn't mean that the rest of the desert, like, they're both necessary for each other. If you only preserve the watering hole, then the rest of the desert is like where the animals live the rest of the time, or critical to how the plants thrive is having that kind of drier environment around them. So it's not as simple. It's not, you have to pay attention to what's going on in the landscape as well. It's not distributed evenly. Another example I have is of this polluted stream, which you should probably look at and think like, wow, that's a horrible place for biodiversity. But then if you look at a natural salt flat, you probably think like, oh, that's like a really interesting place for biodiversity. Why are these different? Should we get rid of the salt flat? It's a polluted area and replace it with a healthy, non-polluted, non-salty flat? No. So this is an instance of there being a kind of toxic environment which causes specialized creatures to evolve there. There's fewer of them because it's a toxic environment. It's difficult for life to live there. But if you have toxic environments intermingled with not healthy, with hospitable environments, let's say, it's called heterogeneity, that increases, when you have both those together, the types of life that can live there. And so that increases biodiversity to have places that are hostile to other types of biodiversity. So just keep that in mind. Polluted streams then are, I mean, there's a temporal effect because it's a new thing. Things haven't had a chance to adapt to it, and it probably won't stay forever, so then things can't live there forever. But to some respects, it's not just sort of a black and white, totally negative. It could also be a place for life to thrive in different ways. Fragmentation, similarly. If heterogeneity is good, why don't we like cut up the habitat and have all different kinds of habitat? Well, as you probably are familiar with, having big areas is important because some species need big areas in order to survive because the food that they eat needs areas to survive in, and so you kind of have to have a large enough area to support its food. But if you just measure on the edge habitat, you'll find more species. This is kind of like the desert thing, where like many species will go into the edge, but they don't need just the edge, they also need the rest of the habitat. That being said, overall, I think if you had more edges, and as long as it wasn't all edges, in general, having more heterogeneity, more diversity, more edges, and different things next to each other, I think that does increase biodiversity. As usual, it matters how you do it, but it's not just fragmentation bad. I think fragmentation is probably good when done non-destructively. And when I also want to mention, probably the most biodiverse places in the world are going to be arboretums, tended gardens, where you have more biodiversity anywhere else, but of course it's artificial. Another example of disturbance is these crazy destructive wildfires, but as someone who's grown up in California, we consider this type of disturbance good. Once again, it supports species that are specialized to it, and having these different types of habitats and having these disturbances can increase biodiversity. However, thinking about the most biodiverse places in the world, that is the tropics, which are one of the most stable places in the world. And having that stability and having, I mean, they also have a lot of sunlight and they have a lot of water, which is also incredibly important. But having a stability allows this incredible specialization where species will, like there'll be a parasite that only goes onto a certain, let's say, bee, and that bee only goes to a certain flower, and like each of those only, they're all specialized so much onto the one single thing that there's just more diversity because there's these smaller niches that are incredibly specialized. Now, another thing about biodiversity is just looking at the raw species number maybe doesn't convey what we think. So biodiversity, we tend to imagine having like just like all kinds of totally unlike each other species. But of course, if you just do a raw species number, maybe you have like 5 of the same flower and like 1 bird, or you could have birds and a bee and a plant. And so like biodiversity doesn't necessarily convey the full variety of life that's there. That's can be calculated, but it's not necessarily called biodiversity. Oh yes, and these are all different species, just to be clear. This is Manzanita, and it's known for having many closely related species. Last example, going back to the deserts. Again, deserts look very species poor. They mostly are, but it matters a little bit what time you go. After the rainfall, you might have a huge temporal burst of biodiversity that's only there for a short period. But something else that you might notice about blooms like this is that we think of them as beautiful and perfect, but you might also, if you're being literal, look at this and be like, wow, that's a monoculture. That is all of one species. That's not good. Well, it is good in this way. We celebrate this type of bloom of all one species here. We wouldn't do this other places where it's been invaded by a non-native plant. We call that bad. It's a monoculture. It's not good for the environment. So I just want to point out some of the kind of funny hypocrisies and things that we're not used to looking at the same time. Biodiversity is a very complex thing that doesn't necessarily measure what you think it does, and can be difficult to measure because you have to take into account the surrounding area, and you have to take into account the temporal diversity and the things that the species need. Maybe it's good to have all of one habitat because then you get these species specialized in these big ranges. Maybe it's good to have lots of edge habitats or disturbance because you get species that specialize into that. Maybe having very hostile environments is good because you have species specialized in that. It's the whole complete amount of biodiversity, right? So to summarize, the total extant species is not the same as the local species density, which is not the same as just sheer amount of life and biomass. Again, monocultures, maybe not what you want. So what are the optimal conditions for biodiversity? Well, it does matter the whole picture. If you're designing one small area, probably, the most biodiverse areas are those tropics, right? So plenty of water, plenty of nutrients, plenty of sunlight, but maybe with patches that are like too dark for sun and too dry, and heterogeneity from all these other factors, lacking nutrients some places, plenty others, a whole mix. So just having that kind of broken upness is important. But again, like disturbance, net gain, net loss in biodiversity, it's complex. I don't know. I don't have an answer. That's why I want to bring it up. It's a lot of things. All right, so I want to next talk about climate change and biodiversity. This is where the highest abundance of species are. This, I think, is mammals, but I think it's roughly the same picture for plants and insects and birds and so forth. Generally, lots and lots in the tropics, and less, definitely less in deserts, and definitely less the further north and south you get. And that's probably due to the frozen climate and just the harshness of trying to survive in places that are frozen so much of the year. But just this is the general pattern. So what might you think about this in relation to climate change? If you're just looking, we can kind of tell averages for different habitat types. Deserts, on average, have low biodiversity. Tundra, on average, has low biodiversity. So if you are just looking at the way the habitats are moving around the globe, you can make some predictions about biodiversity. You'll have more areas with higher biodiversity. You'll have less tundra and more tropics until it turns into a desert, I guess. So wouldn't that just mean an increase in biodiversity? Here's showing how the movement is anticipated for the next 25 years. And yes, you see tropics look about the same, I would say, but we're losing some of that tundra, and all the biomes are kind of moving upward and outwards there. So that would indicate like a net increase in average biodiversity on Earth. Like for every area, there would be more average biodiversity. And so here's some other examples of how climate will change just in the United States. And this really cool paper describing how there'll be some disappearing climates that will no longer be extant on the globe, and then some novel climates that will be appearing. Most of the action is in those tropical areas. So that would potentially be an increase in areas of biodiversity and so forth. But it could also be, well, that would indicate an increase. However, that's not the same thing as the total number of species on the planet, because if species are going extinct, that's just a decline in species, even if the average area has like more biodiversity. So the total global biodiversity will be going down, even as the average global biodiversity, like the average area, will have more biodiversity on it. So just wanted to give that to you think about. There's positive aspects of climate change. Of course, there's the negative ones we're already very, very familiar with. So climate change is still not good, but it's not a simple picture, and I just want to convey that. So let's talk about biodiversity over time. So in general, you have an increase in extant species over time as more species evolve. Now you might not assume that to be the case. You might think like, well, the Earth can hold only a certain number of species. And then once we reach that, then there just isn't any more niches available to fill, and then it just tops out. But that doesn't seem to be true. Actually, evolution seems to be able to create new niches, but it's also not always going up, which is surprising. You might think, okay, if evolution creates new niches, then they'll always create new niches. Well, sometimes during our geologic history, there has been kind of a plateau, but it hasn't always plateaued at the same point, and so that's very strange. And we should talk about that a little bit. That seems to indicate, as like, this is not my idea, this is what I've read from other people, that seems to indicate that the extinction can kind of set the future evolution rate or plateau. And that seems very, very strange and very, very huge, important, because then extinctions aren't just affecting what's currently going on, but they're affecting the entire potential future as well. So that's scary, very, very scary. But there's also a lot of good news. For example, at present, we're the highest Earth has ever been for species and genus, by the way. So that's why I would think like, oh, this is just scientists have more information about current things, and so they just think that there's more species because they can see it more clearly, right? But of course, studies know to correct for that, and they have done both species and genus, and both seem to indicate that there's more than there ever has been. Furthermore, yeah, so as I said, it's very odd that sometimes the amount of biodiversity, the number of species that are extant, will be at a lower level than it was in the past, and that just seems kind of crazy, but it does happen. We've seen it. Yeah, so that's just some kind of really interesting stuff I wanted to share. A final note is that a good example encapsulating this is when you have a mountain and climate change is occurring on the mountain. you'll be having those kind of lush, supportive environments that are very like easier for life to live in than say like the very rocky, topmost alpine environments where it's difficult for life to survive. With climate change, you'll be having those lush environments moving up the mountainside, so you'll have more, on average, biodiversity. But of course, the species at the top that existed there before, they don't have any place to move up to, so they're dying. They're dying off the mountain. They're no longer on the mountain. So you'll have this increase in average, but you'll have this decrease in total for the mountain environment. So that is, I think, a good summary of what I was trying to convey there. And I hope that that kind of made you question some things or made you think a little more deeply about what biodiversity is and what it means and how important it is. Thanks.